With Kubernetes as your underlying platform, it is absolutely insane what you can do, from using things like Crossplane to Kubevert to all the other tools and capabilities that are available out of the box and adds add-ons with Kubernetes. My name is Michael Levan. Thank you so much for checking out this course. The whole idea here is I'm going to take you through 3 different parts to build a platform engineering environment on Kubernetes. So thank you so much for joining, and I hope that you enjoy the course. Hey everybody, welcome to the course on building a platform engineering environment on Kubernetes. So what we're going to be doing is we're going to be taking a look at everything from the underlying platform layer, so Kubernetes itself, but maybe it's on-prem, maybe it's in the cloud, etc. We're going to talk about platform capability, so what we can actually do on the cluster, things like Crossplane, Cluster API to have the ability to build other Kubernetes clusters, and a whole lot more. And we're also going to see some interfaces, so how we can actually interact with our Kubernetes environment, or our platform rather, that's built in our Kubernetes environment. So thank you so much for joining. Really appreciate it, and I hope that you enjoy the course. Hello everyone. Good morning, good evening, good afternoon, wherever you are in the world. My name is Michael Levan, and what are we doing today? Well, we will be talking about day 1 of building a platform engineering environment on Kubernetes, right? So if we go ahead and just do the quick screen sharing goodness here, my Stream Deck, of course, is not working, but that's totally okay. So this is exactly what I'm referring to here, okay? So I posted this out. I talked about it a couple weeks ago, talked about what we were going to be ultimately doing here. And this is all about day 1. So what's the idea here? What's the gist? Well, the gist is this. Day 1, you need to worry about your underlying platform. Day 2, you need to worry about platform capabilities. Day 3, you need to think about interfaces. All right. So, we have the day 1 ops, the day 2 ops, etc. I'm kind of taking the same approach here with, day 1, day 2, day 3 platform engineering. Okay. So first and foremost, if you have any questions as I'm going through this, please let me know. We are going to be talking about building the overall platform today. Okay. So let me go ahead and share VS Code. And we're going to kind of do a walkthrough of what we will be discussing, right? So first things first, what is day 1? Day 1 is all about getting your Kubernetes cluster prepared, okay? Now, this is what I will say right off the bat. All of these topics, security, management of a Kubernetes cluster, creation of a Kubernetes cluster, securing a Kubernetes cluster, what you got to understand is these are all topics that take up hours and hours and hours of courses within themselves. These topics take up books and books and books. Why am I saying that? Because we got about 30 minutes to an hour together today. And what that means is we can't go over everything, because I can't expect everybody to sit here for 16 hours listening to me, nor can I expect my brain to operate at that frequency for 16 hours straight. Sometimes I could expect it. I have some Death Wish coffee here, so maybe we actually could do that today. All right, so the whole idea of the underlying platform. What is the underlying platform? Well, it could be a couple of things. Number 1, it could be Kubernetes. Number 2, it could be virtual machines. Number 3, could be bare metal. Heck, it could even be Amazon or AWS, ECS, Elastic Container Service, or Azure Container Apps, right? It could be a lot of different things. The underlying platform, right? This is where your platform capabilities will exist, okay? So I actually want to pull up something here on my end if I can find it, but I created this little diagram thing here, which I believe will help bring this point home. Of course, I can't find it, but the whole idea is this. You have your underlying platform, which again, could be Kubernetes, it could be bare metal, it could be virtual machines, it could be, a million things. And let me just go ahead and share this out here. Share screen, this right here, okay? So you have your underlying platform. Again, Kubernetes, bare metal, ECS, it could be anything that's running your platform capabilities, right? What are your platform capabilities? Your platform capabilities are what you want users of your platform to be able to do. So do they need to do the GitOpsy thing? Do they need to do the monitoring and observability thing? I certainly hope so. Do they need some capabilities like crossplane to create resources outside of Kubernetes, right? And then you have your platform interface. And this is how you're interacting with the platform. So once you build up the underlying platform, once you put in the platform capabilities, the internal engineers and developers and whoever else is going to use the platform then need the ability to interact with the platform. Okay. So what does this mean exactly? Well, what it means is it could be some type of GUI, right? So maybe it's Backstage, maybe. Or it could be a CLI. So for example, maybe you create a command line interface and that command line interface gives you the ability to interact with it with one command. And I'm going to showcase that a little bit, I think tomorrow or Wednesday. And by the way, again, if you're just joining, please feel free to ask any questions. I will be live streaming this day 1, day 2, day 3, tomorrow, Tuesday, and Wednesday at 12 p.m. US Eastern. So we're going to dive into a bunch of different topics here. All right. So this is the gist. Now, today, we're going to be talking about the underlying platform. And the underlying platform, funny enough, it's not much different than you may be thinking. You may be thinking to yourself, well, if my underlying platform is on Kubernetes, what does this underlying Kubernetes platform need? Well, it needs a couple of things. It needs security. It needs authentication. It needs authorization. It needs scanning. It needs best practices. It needs automation, etc. It needs a bunch of different things. So if I go ahead and if I share my screen here, we're kind of talking about all this, right? The scanning and the security and all that stuff, right? So what is needed? Let me go ahead and just zoom in a bit here. What is needed? Well, security, right? All aspects, whether it's CIS benchmarks, whether it's a scanning tool, whatever it is. Next, of course, again, scanning, cluster scanning, scanning images, scanning Kubernetes manifest. It could be whatever type of scanning you need to do. And then automatic remediation, maybe. Authentication and authorization. So authentication, logging in, authorization, permissions, what you can do once you're logged in. Creation. You need to be able to automate the creation of a cluster, right? So writing the code, deploying it, etc. Management for day 2. Upgrades, maintenance, alerting, monitoring, and observability. Now, if you take a look at all those things, you should, maybe you're scratching your head right now and you're wondering, well, this looks like any other Kubernetes environment. And spoiler alert, you're absolutely right. It is like any other Kubernetes environment. We're not reinventing anything new here with platform engineering if your Kubernetes cluster is the underlying platform. Again, we're not reinventing the wheel here. What you're going to be doing in any Kubernetes environment from a production perspective, if you're doing it the right way, it's going to look like this. So whether you're implementing platform engineering practices, whether you're just implementing Kubernetes as a dev or whatever, you're going to be following these things regardless. So point being, you're not reinventing the wheel. But here are a couple of other things we have to kind of think about. Proper SLAs, proper teams. Now, why does that matter? Because as we go through this, and especially we're going to be talking about this tomorrow and Wednesday, again, 12 p.m. US Eastern, our platform that we're building, right? That's comprised of the underlying platform, the platform capabilities, and the platform interface. This is a product, right? That's where DevX or developer experience comes into play. It's where customer service comes into play. It's where the product mindset comes into play, okay? This, what you're building here, the platform, it is 100% a product. You are building a product. What that means is things like SLAs, things like who's managing it, things like, do we have a product manager? Who's running product here? Is there a Jira board with all different requests from our customers? Our customers and our clients are the internal engineers and developers. So outside of the technical piece, there is this product, developer experience, and customer service experience focused mindset here that we need to be thinking about when we're building it as well. All right. So what does this look like? What is, the overall environment look like? Well, let's start with this. Now I have Kubernetes environment, kubectl, get nodes. I'm running AKS, got 3 worker nodes, right? So this could be your underlying platform. But what else could your underlying platform be? Well, let's head over to the GUI really quick. And let's go to Proxmox, right? So if I log in here, you're not familiar with Proxmox, to type one hypervisor like ESXi, like Hyper-V. So I actually have a bunch of environments here running, and you can't see it, of course, but to my right, I have an Intel NUC Extreme, and that's running my Proxmox environment. I should probably get a couple of others because I want to continue to build out my home lab more and more, right? But as you can see, I have a bunch of VMs running here, right? So these VMs will also perhaps be my underlying platform. So my underlying platform could be bare metal. It could be virtual machines bootstrapped with kubeadm. It could be, excuse me, a cloud environment like EKS or GKE or whatever else. Okay. So out of context, what's your Visual Studio theme? I think it's the Cyberpunk 2077 one. Yeah, it actually is really cool. It's one of my favorites. Yo, what's going on? All right. So if I, for example, open one of these up here, let's see if I can somehow, actually, you know what? I'm just going to share the whole screen here. Give me one sec. Entire screen. All right, cool. So this is the entire screen. Proxmox is in the background. But this is simply an Ubuntu environment, right? So I'm going to open up this one and just going to hit this really quick. This is going to do a little bit of a reload here. All right, well, I'm not going to go through Ubuntu, the installation, yada, yada. But what I want to showcase here is this virtual environment. This could be 100% running your Proxmox environment, okay? So we're going to come back to this in a second here, but I'm going to do a quick login. Right. So I have one control plane and I have one worker node here. So again, I'm going to hit this one more time. Wait for this to come up. All right, and I'm going to log into these. So if you're doing any type of following along or anything at home, essentially what I'm doing here is I'm just getting two virtualization environments up and running. Again, these are type 1 hypervisors here. Let's see what we got. Give it a second. Mike and password 1. All right, so we're going to come back to these in a second here. So let's head back over to VS Code. Is Proxmox free? Yes, it is. You can also download the free version of ESXi if you'd like to, and Hyper-V if you want to run a Windows Server box, right? So we are now back in VS Code. And what I want to do is I want to talk about the creation of a cluster, all right? So first things first, there are a bunch of different methods for creating a cluster. And these links here, I'm going to showcase the overall configuration on-prem, but you can also take a look at the code here for AKS and the cloud code. I think I just combined those two words for EKS. The next piece of this is going to be how you want to deploy the environment in the cloud, right? Or on-prem. Now, maybe you'll write into HCL, right? So maybe you're doing some Terraform code. Maybe you're going to use something like Pulumi, or you're going to use CloudFormation or whatever you're going to use, right? Point being of this piece here is you want to automate this process. The second piece is the overall method of how you're deploying, right? So if I'm writing a bunch of code, I don't want to go on my terminal and do something like Terraform apply auto approve, right? Like I don't want to do that because number one, that doesn't scale. Number two, no other engineers can use the environment to deploy it because it's my personal computer. Number three, there's no central method of doing that, right? So that's where something like, excuse me, CI/CD can come into play, right? So what I want to do is I'm going to pop open these two pipelines, and I'm going to showcase what this ultimately looks like. All right. Let me hop back over to the browser. There it is. All right. All right. So let me zoom in here a minute. Okay. So once you write the Terraform code, again, I just showed the Terraform code. You can go back, you can take a look at it, right? Once you create the Terraform code, you're going to need a way to deploy. And again, if you're just tuning in, we are talking about day one platform engineering, how to build the underlying platform, right? So now we're in the part of talking about the cluster creation. So you have a couple of different methods, but again, I highly recommend deploying the Terraform code or however, whatever automation you're using, deploy it via CI/CD. And the pipeline can be incredibly simple. So as you can see, I have an EKS pipeline here. And what am I doing? I'm getting the Terraform job running on the underlying container that's running my GitHub Action workflow. I'm checking out the code. I'm authenticating to AWS. And then I'm doing the Terraform init format plan apply, right? So you can do it this way via bash. I know I think there's like one or two workflows in the GitHub Actions marketplace to do the Terraform thing, right? Without having to do it in bash like this. But what I will say is I don't believe any of them are official. So when it comes to actions and workflows and stuff like that within the marketplace, I do prefer to go with the official ones, right? Because if they're just hanging out in somebody's GitHub repo, I don't know if those actions are going to continue to be updated. I don't know if they will they might not be there in a year. I don't know, right? So that's why I'm going with this method. And then I could do the same thing with AKS, for example, right? A little bit different. I'm authenticating to AKS, but the overall commands are the same. Init, format, plan, apply. I'm doing the same thing. I'm just doing it for, again, AKS, right? And then I can also automate the destroy, right? And the destroy for AKS and EKS, it's the same. Literally, the only thing that's different is I'm changing the command from apply to destroy, right? So that's the gist, right? So I want to head back over to VS Code. I really wish my Stream Deck was working. I don't know why it's not. So I'm clicking and clacking around instead. Okay, so you create the code. Again, here are the links, right? I'm going to put these links in the chat. All right, I just put those links in the chat. Okay, so you do that. Next thing is you create, a CI/CD environment, right? I'm going to go ahead and I'm going to take these links. I'm going to put them in the chat. All right. So the first piece, that's the first piece, right? You have to, number one, you want to create a cluster. Number two, you want to get that cluster up and running. Number three, you want to automate getting it up and running, right? So how do you get it up and running? You have the repeatable process, right? Writing some code. Next, you want to take that process and you want to make it even more repeatable because you don't want it on your terminal, right? You want it in a place where people can click a button and kick it off, right? So that's the creation process. The next process is management. Okay. Oh, actually, you know what? I'm going to go back to that in a second. I'm going to go to authentication and authorization first, right? So from authentication and authorization, you have this internal method, right? Using standard RBAC. So this is the kind or the object. This API is built into Kubernetes, right? So this is again, the authorization method. This is the permissions. Two problems with this. Number one, trying to manage a bunch of users, teams, or they're called groups in this configuration, or service accounts using the YAML methods here. It's a major pain in the butt, right? Maybe works great if you have one or two service accounts and one user, but what if you have 50 users, 20 teams, and 100 service accounts? Managing all that YAML for each one is going to be really cumbersome. So that's number one. Number two, there's no authentication. So built into Kubernetes, there is no authentication. There's just authorization, right? So technically, you can handle the user piece of it, the authentication piece, with Linux users and Linux groups, like literally managing them one by one throughout, worker nodes and such. I don't recommend that. Actually, I'm going to tell you right now, it's a really bad practice. Don't do it. I just bring it up just in case somebody says, well, there actually is a way. That is the way. It's just not good. All right. Now, what is the next approach? Well, the next approach is an OIDC method, right? An OpenID Connect method, a IAM method outside of the general RBAC. So you got a couple of different options. You got AWS IAM, you got Azure Active Directory, which is the one that I recommend, and then you got some open source solutions like Keycloak, and then you got some other like enterprise solutions. We'll call them like Okta, for example, and there are a bunch of other ones as well. But the point is this: you want one tool, one method, one approach to handle authentication and authorization. You don't want to fumble around YAML. You don't want to fumble around Linux users. You want one method. So let's go ahead and take a look at those methods, right? So I'm going to open up the terminal. I'm on an AKS cluster. I personally like Azure Active Directory, but remember with Azure Active Directory, you can use it outside of Azure as well. So if you have an EKS cluster, GKE cluster, there are options to use it outside of just AKS clusters, right? So first things first, I'm just going to create this new user, right? Go ahead and create that. Let's see, what did that tell me? Oh, of course, I already created one with that. I think I already have one as well with this. And if I do, we'll just move on to that. Yeah, of course. All right, so so you can tell I've done this a couple of times. So I create the user, right? Next thing is I want to see what roles are available. Like I want to see what permissions are available. So if I scroll up, we can see I got a bunch of different permissions. I got cluster admin, I got service admin, I got reader, and a couple of other ones. So this is the authorization approach that I can take. And by the way, I will show how this looks in the GUI as well once we're done with this. The next thing that I can do is I can assign this user to my cluster and give it a particular role, right? So I'm going to go ahead, I'm going to run this. And just like that, I have handled the authentication and authorization process of my cluster. And if I head over to, I know there's a couple of questions, I'm going to get to them in just a second, but if we head over to the portal here, I'm going to share my screen really quick. Log in. I can do it in the GUI as well. So if I come here, I go to my cluster, go to IAM, I click add role assignment. The first thing is I can choose what role I want, okay? So if I choose the role here, maybe, service admin, for example. So I've just done my authorization piece. Now I'm gonna do my authentication piece. Select, choose AKS test, for example, right? So this is my authentication piece. This is the user that's gonna be logging in. Boom, done. Authentication, authorization, complete. Now to do those two things with VS Code, for example, or not with VS Code, with the RBAC API, come back here, I would have to create the role binding, the role, and the user itself. Now I'm not going to go through what each of these means, cluster role bindings. I'm assuming you already know it, okay? But I wanted to just show that to make a point that I can cut down my time, have an enterprise solution quickly versus, fumbling around with YAML, right? I can do something like Azure Active Directory, or I could do something like Keycloak. So Keycloak is open source IAM, right? So if I go ahead and if I just create the instance of Keycloak, I did it in the default namespace. So kubectl get service, right? You can see that's pending. Let's see, once that changes, I should get an IP address here in a second. Because again, I'm running AKS, right? So it's going to automatically create a cloud load balancer for me. So, oh, there it is. All right, perfect. So I now have that IP address. I'm going to go ahead. I'm going to take that IP address. I'm going to open up the browser. Let me share my browser. I think it's over 8080. I think it's going to take a second or two, of course, to come up because the pods are still loading and all that jazz. But we're going to give it a second here. It's loading up. Again, I think it is, yeah, it's 8080. All right, so we'll give that a sec here. And I'm going to go ahead and I'm going to answer some questions while we're waiting for this to come up. First question, will the recording be available? The overall recording of this will be available on LinkedIn. you can go back and you can watch it. It will not be available on YouTube, but what I will be doing is I will be taking this live training recording, chopping it up and turning it into a course, right? Just so everybody knows. ETA on that, I'm not 100% sure, probably within the next month or so. Right. Will we get your repo access? Yeah, if you hit any of those repos, actually, it's a good question. Let me come over here and let me share out this repo. Where is it? This one. Yeah, let me share this out. This is a public repo, so you can go ahead and you can hit that repo. Okay, cool. So next question here. Considering a scenario where you may have multiple Kubernetes clusters, Terraform code in the same GitHub repo, but in different directories, how do you manage for the pipeline to run only a specific environment? That is something called Terraform workspaces. Look it up, but essentially Terraform workspaces allow you to split it up into like whatever environment. So for example, I typically do like dev, staging, prod, so you can split it up into different environments. Really good question. By the way, I did just put out the complete repo for for the live training again today, tomorrow, Wednesday. I will be doing this live training at 12 p.m. US Eastern. All right, so Keycloak is up and running. We can go ahead and we can hit that repo, or I'm sorry, that URL. I think the default username and password is admin. Okay, and then boom, just like that, we have our environment up and we can manage users, groups, etc. Now, please keep in mind, again, this is an open source tool for IAM. So the configurations based on environment will be different, right? So like, for example, if I just do authenticate to AKS with Keycloak, and I pop that in here. All right, you can see some configurations here on connecting Keycloak. Actually, I think this is actually a paid tool, so never mind. You don't have to worry about that. But I think this is like a free configuration that you can do as well. But remember, it's going to be different. You do something like EKS, right? So configuring Keycloak for EKS versus AKS, these are going to be different in scenarios, and that's exactly why I didn't put the scenario into this training. Maybe I'll put it in the video course, because the video course that I'm going to be creating out of this live training, I'm going to be adding a bunch of stuff to it as well. So maybe I'll add like different scenarios. But again, the scenarios are so different depending on the cloud that you're in, or even if you're on-prem. So just, keep that in mind. You're going to have a different, identity provider configuration for AWS, for Azure, for on-prem, etc. And of course, please ask questions if you have any questions. Don't have to wait until the end or anything like that. All right, so we'll go back to VS Code. Now, the next piece of this is management. All right. So actually, you know what? I'm going to save management until tomorrow, I think, because it's already 12:30. I probably should have done 4 days for this, to be honest, but it's okay. Right. So I'm going to save management until tomorrow. And if I accidentally forget, I'm going to take a note. But if I forget, please remind me, call me out on my BS. All right. So coming back to security, the first step in security. So we've authenticated and authorized for our environment. We've written the code to create our environment. We've created a pipeline to deploy our environment in an automated fashion. Now we got to kind of come back to security here. CIS benchmarks. These are the two best places to start, right? And I'm going to actually pull up one of the reports on my end here. Bear with me a sec. Yeah, I have one for Azure actually that I'll go ahead and then I'll pull up so everybody can see it. But these reports, you can download them for free. Just Google CIS benchmarks for Kubernetes and you'll be able to download them for free. And I also put a couple of PDFs in the repo as well. But this is what a CIS benchmark looks like, okay? So if I scroll down here, I'm not going to go through it all because it's 162 pages. The standard Kubernetes one is like 217 pages, right? But what I like about these reports, tell you the level, the description, the explanation, the rationale behind it, And then it'll also give you the remediation. Again, if I just scroll down here and I pick a random one, it does the same thing. Applicability, description, rationale, fix, right? So here's what I like about these reports. They're practical, they give you the remediation steps, and they give you the why behind it. Now, here's what I'll tell you. You probably aren't really excited about reading 200-page reports, right? I get excited about reading 200-page reports, but I am an odd duck. So if you don't get excited about reading all those reports, what you can do is you can use a tool that has the ability to I'll call it automatically read those reports for you. And one of my favorite tools that I use is Kubescape. Kubescape, they have a open source version, they have a paid version. You don't need to pay for it. You can just use the free version on the CLI, and then even the free version on the GUI. I think you can monitor like up to 1 or 2 clusters. So you can check it out 100% for free, and you don't have to pay for anything, right? But you can also just use the CLI as well, the command line, and it's 100% free. Okay. So here's what I want to do. I want to show you what it looks like on the GUI. Let me just go ahead and sign in here. Kubescape. I'm just logging in here on my end, and then I'll share my screen. Bear with me. Uno moment. Un moment. Un momento. All right, cool. We are logged in. Share screen. All right. So the cool thing about Kubescape is what ends up happening is it is pulling all of, let me go to the vulnerabilities here. No, actually, is it under compliance? Yeah. So notice here how automatically for you, it is pulling best practices, Armo's version of scanning and compliance, but it's also pulling MITRE, it's pulling NSA, and it's pulling CIS. So CIS, NSA, National Vulnerability Database, these are all compliance databases. What are the compliance databases made out of? Security best practices for your environment, right? So for example, instead of reading a 200-page report, you can just use a tool like this that implements CIS. And there's also Kubench does this as well. I believe Checkov does this. And I know there are a couple of others, but point being is, you know, if you want to use one of them, but a lot of them are implementing CIS and a lot of them are open source, right? So for example, if I click on this, what I can do is I can scroll down and I can see, let me actually zoom out here. Okay, so I can see the problem, the severity, the remediation, and what's cool is if I click this fix button, what it's going to do is it's going to bring me to the code, right? So essentially what it wants me to do is it wants me to add in some code to fix the issues, right? It won't automatically do it for me, but I can take the code and I can add it in, right? If I don't want to do that, I can just at least get the remediation steps and the reasoning behind it. So again, from a security perspective, like I said in the beginning of this call, everything that we're talking about here today in a time span of 45 minutes, remember, these are all topics that span plenty of courses and plenty of books. And I only got 45 minutes with y'all, so I can't go through everything, but what I can do is I can tell you really great places to start. And take a look at my other content, blogs, videos, books. I put all this stuff in my other pieces of content as well. And then you could use something like Kubench. So what Kubench does is it actually scans your cluster against CIS, and it comes back on, you know, all of the vulnerabilities, all of the issues, and all that jazz. I think Kubescape. I thought I had it on here. Maybe I don't. Let's see. Let me cd. Actually, hold on. Kubescape CLI install. I think I'm sharing VS Code, right? Yeah. Give me 1 sec. I'm just gonna. What is the command? There we go. I had it installed. Apologies. All right, I'm gonna put it in my path. Cool. All right, so what I'm gonna do here is this. Again, I got an AKS cluster. I'm gonna run kubescape scan. So this is gonna scan everything. One sec, I think I have a sneeze. Nope, went away. I really hate when that happens. Okay, so what I can see here is, and by the way, this is the Kubescape version that's 100% free. It's open source, so like you can run this a million times, it doesn't matter. But this is really cool because it tells me the overview of my security posture, tells me a couple of different other pieces of information, tells me what's missing, it tells me the category of which it's missing from, and then it'll also tell me the compliance score that I have. All right. And of course, I can scan it based on, compliance frameworks as well, or I can just scan all of it. So definitely an awesome, capability here, right? Kubescape looks awesome. Yeah, Kubescape is really cool. Definitely a really cool tool when you're first starting out your security environment, when you're first starting that journey, because like I said, there are so many different factors that come into Kubernetes security that they take up books and books and books and courses and courses and courses. But to just start out, a really great place is Kubescape or Kubench or another tool and method. All right. So what are we building? We are building a underlying Kubernetes platform, right? Got a couple of links up as well. Just take a look at the comments. Link, please. I'm sorry, which link are you referring to? You're referring to Kubescape? Not sure, but if so, definitely just Google Kubescape and you'll come up to the Git repo. Yeah, Kubescape is awesome. Definitely take a look at it. It's one of my favorites as well. Now, another section or piece here that I'll tell you all to take a look at for security. The Kubernetes OWASP top 10. Now, this hasn't been updated since 2022, but it's still pretty relevant. So OWASP, very reputable foundation, right, around security in general. But there's this top 10 here, and if I click on this, what it'll do is number one, again, if I go back, here's some top 10 vulnerabilities, right? If I click on one of them and I scroll down, it'll give me the overview. It'll give me this little infograph. It'll give me the description. It'll give me some rationales, and then it'll give me some code examples. So for your underlying Kubernetes platform from a security perspective, if you take a look at OWASP top 10, and if you take a look at Kubescape, you're gonna be going in a pretty solid direction, right? Okay, so next part here, where are we? Let me exit out of here. All right, so we went over authentication authorization. We went over some PDFs. We went over creation. We went over scanning, all right, and we went over what is needed. So tomorrow, what we're gonna do is we're gonna go over a couple of different tools. Tomorrow's session will end up probably being longer. It'll probably end up being like double the time of today's session because we're going to talk about management and we're going to talk about security tomorrow. And then we're going to talk about how to configure a whole bunch of capabilities. And then Wednesday, we're going to be talking about a couple of different solutions as well, from a homegrown perspective, from an open source perspective, from a paid perspective, and from an open source perspective for interfaces. So again, what I want to just showcase here is if I quickly share this not that diagram. Where is the diagram that I want to share? Give me one sec. I shared it before in the beginning, but I just want to share it again here. Share. Okay. So today we went over the underlying platform. Tomorrow, we're going to touch a little bit more on the underlying platform as well. And then we're going to go into the platform capability section, okay? Then on Wednesday, we're going to talk about the platform interfaces, things like internal developer platforms and various different methods of interacting with various capabilities, okay? So before we wrap up for the day here, I just want to check in. Does anybody have any last final questions? So again, tomorrow we're going to be diving a little bit more into a couple of more pieces into the platform, the underlying platform. I need to go over the Proxmox stuff as well with you in terms of setting up the on-prem configuration. So we're going to be going over that. Because of how lengthy tomorrow is going to be, it's probably going to be double the time. So I would assume an hour and a half to 2 hours. And then Wednesday, we're going to go over the IDP pieces. Again, today, tomorrow, Wednesday, we're doing this full live stream, 12 p.m. US Eastern. Don't see any other questions that are popping in here. I'm just checking on LinkedIn comments as well. I don't think I see anything specific. No. Please show the last screen visual again. Yeah, for sure. Let me pop that back up here. Another question, can we watch this session later instead live on YouTube? No, so I'm not going to be, the recording will not be on YouTube, but I will be creating a course out of this training, and I'll also be adding a bunch of other stuff to the course as well, probably within the next month or so. And here's that diagram again. I'll give you a second to take a screenshot of that. My question isn't about Kubernetes, by the way. Thank you for all the information. Thank you in advance for the, but what are your thoughts on GitHub Actions? GitHub Actions, Jenkins, and GitLab, I would say those are the top three in terms of CI/CD. Totally fine. The underlying platform and platform engineering as a whole does consist of CI/CD. CI/CD is a huge piece of it, so definitely ask any CI/CD questions as well. Cool. All right, y'all. Well, thank you so much. I appreciate you tuning in. Definitely catch the session tomorrow, 12 p.m. US Eastern. We're going to be talking about a bunch of different things. We're going to be talking about platform capabilities. And we're going to be wrapping up the underlying platform. Where would the course be available? I'll probably be putting it on Gumroad, but just give me like a month or so, and then I think we're going to be popping that stuff up as well. Yeah. Cool. All right. Well, thanks, y'all. Appreciate it, and I'll see you tomorrow, 12 p.m. US Eastern.